Hmm. Ding. Paste all the things. All the pastings. Right? Anything else? Any place else that I need to do this? Maybe on the Discord. I don't know. Go. Go, 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 go. Okay. All the places. I kind of like how the class is going. So, yeah. I am gonna do a just sort of quick design session over the Summer Protocols project and just sort of like do like a high level like how I am refactoring this code and how it actually looks, and maybe I'll draw like how it looks right now and then draw how it is going to look. So first of all, there's a context object, and that is sort of like a marshal for all of the components. It had erstwhile been a it would have a contents of it would be it would have like a graph database inside of it, and it would have a bunch of code. It would also have like a document class. And it would reach out to the file system. It would pull that in. It would do things like, and it would just generate the stuff to a target. So it would pull a file out of the file system, match it to statements in the graph, and then generate a document instance that would have like operations on it, and that would go to a repository that gets sent to a server. And oh yeah, I got to make sure that I don't. I got to give myself the little corner that my head is stuck in. But anyway, so on top of this, I added a resolver. And I also added a mix-in for the graph operations. to basically shortcut a lot of inference stuff that the graph, like I needed to just do inferencing in a bunch of ways, a bunch of places. And so this is new and this is new. And there's like a couple of like functions in here. Like I'll do the function as in the flowcharty way where the entities are square and so there's also a like generator for different things, and then that goes into the repo as well. And then just all of this just gets bundled up and packed and sent to a server. So what I want to do is a few things. First of all, the fact that these generated things are part of the context, that's bad. And this sort of notion of a document that's separate from these generated things is also bad. And the notion that the file system access is hard-coded, or effectively not hard-coded exactly, but it's like the only option, is also bad. And these are okay. There's also sort of a config operation, config parsing operation that happens in here as well, which has to do with the file system. And so what I want to do, these are okay. I want to driverize this. Just, I don't have my nice, that's right there. If that's right there, I'm going to get it. I was going to say I don't have my nice colored markers, but I do, but I'd have to unplug and get up and get them. I'll do that in a second. So I want to reorganize this. And the way that I intend to reorganize it is, imagine the flow of the actual use of the thing. So, you've got the user. They make a request. That has to hit the resolver. That resolves it to a subject in the graph, so that then there needs to be some kind of a dispatcher. Oh, and the other thing that the resolver does is it determines the QOPS. So there's transformations that happen in the request. So the job of the resolver is to identify a place in the graph, like a subject in the graph. It's like, do you know about the existence of this thing? If you find it, then you would dispatch between a source, and then you need a surface here. And then that response sends the response. Now the surface is going to have transformation pipeline. So also the sources are going to be multiple. So you can have like file system, you can have content addressable, you can have proxy, reverse proxy, etc. This will find you the thing or it won't. And then that gets passed to a bunch of transforms. I really should have put this down here, but we can do that in the next revision of the document. And put the Q. Because that determines what the transforms are. So I'll just take this off. And if there's a request body, we can also manipulate that. So the recent work was configuring these sources, and I called them sources and surfaces on purpose. So like a source is, you could have used the word origin instead of source, but I use source because a source is not necessarily an origin. And the difference between like an origin and a source that's not an origin is like a reverse proxy. So a reverse proxy, and of course the reverse proxy could be cached, but the actual origin of the information resource could be somewhere else. And so so an origin source would be like it's on this guy's hard drive. The canonical or the sort of authoritative copy is like on this person's hard drive, on this machine's hard drive. And it's not just a copy or a cached instance of it. So this is more in line with what I want the new design to be. And the other thing about the surface is that the surface, there are multiple surfaces as well. So you could have static and you could have dynamic. And the other thing that in here in the sources is generated. And this is very important because this is actually interesting. Let me just sort of think about this here. So there's a couple ambiguities that I've needed to sort of figure out, because like the problem that I've had, and like the reason why I haven't refactored it this way yet, is because I don't know how to configure it. There's a lot of configuration information that needs to go in here, and sort of like dispatching the configuration is an issue unto itself. But the point of the system, of a system designed this way, is to make it so that a lot of the operations are sort of interchangeable. So just as an example, you have stuff like you've got query parameters. You have path parameters. You've also got request body. You've got request method. So, there might even have to be something in here that, like, what we want to be able to do is we want to be able to flatten the space as much as we can about the entropy, like the possibilities that can be in a request in an HTTP request. So we want to be able to reduce those possibilities down to like the smallest possible footprint that still contains the information that needs to in order to have a fully featured system, which is not a foregone conclusion. So like you've got like really practical problems, for example, like say for example, like over here on the file system, you have a file stored in Markdown. But by the time you want it sent here, you want it in HTML, or rather you want it in XHTML or whatever. They're going to send out, and this is headers too. Request, or did I say? No, that's, so request headers. Jesus, learn to write. I'm hoping that if I do more of this, I will improve my penmanship. But, it's not the worst thing in the world if that doesn't happen. Anywho, put that on the floor. Yeah, so this looks like kind of like a complete ish representation. I want to think about it for a second, because I almost feel like there should be something around the resolver, like what. Like, here's an example. So, yeah, let's say that you've got like a mark, like you resolve the URI, so the request URI gets resolved to something that is ultimately represented by a markdown file on the file system over here. And you want it to show up as HTML or whatever over here. So what you want to do is you want to be able to put the transform into the transformation stack, and you want to be able to put that first. And so the request, we want to be able to modify the request. So maybe some kind of like request mangler. Because we want to be able to, modify the headers. So you pass in a header that says, whatever the header accept header says. And this is the other thing about it too, is like you also want the other, the languages and all that other shit in there too. You want to have that in there. But let's say that you got the request header that says like, I want HTML. And knowing the fact that there exists a transform that will transform Markdown into HTML. What you'll do is you will add to the request header an accept a value into the accept header that says, also it's okay if you give me Markdown. So that once you get to the end here and there's only Markdown, it doesn't reject the response. It says, yeah, actually this is valid, this is fine, and you should give it to me. And so, yeah, we want to be able to twiddle the request very, very early on, given the information that we have from the request. So, I guess the thing is like I have this thing called context, and I don't know if that's actually right. I almost feel like I need something that is, that's in addition to that, because I want the thing that parses the request, and I want the thing that, not parses it, but I want the thing that manipulates the request, but also manipulates the request also prepend, transform stack. And the other thing that it would do, I guess it doesn't really matter at that point. I was going to say the other thing that it would do is peel off the what's it called, the request header, but it doesn't actually matter at that point because it'll have already negotiated it. Other things we want to be able to do in the request is manipulate, like rewrite request body. So an example of that is this protocol that I designed called RDF-KV. And RDF-KV will take ordinary key value HTML form content, and it will rewrite that into another structure, so like an RDF diff or something like that. And then the idea there is the downstream handler, which, you know, come to think of it, like updating the handler, you know, so we'll have one for gets, and we'll have one for post. And the other thing too is also flattening all requests can be flattened to either get or post. Because when you think of it, the difference between get and post is what's called idempotence. Or really actually there's like three categories of HTTP request method. There is safe, which is nominally safe. So in the case of get, should be safe, meaning you don't change the state. A get will never change the state, which of course in practice is total bullshit, but it's not supposed to. It's not supposed to change the state. Post, so then there's safe, there's idempotent, so like put and delete would be idempotent, meaning you change the state once. If you put the same thing at the same location, it doesn't change the state a subsequent time. It just changes the state once. You put a resource, you put a representation at a location. It doesn't change. You know, you write a file there, you write the same file there. Nothing's going to happen. If you have a different file, that'll change the state. But that's a different representational state. So for any given request with any given sort of request content that's in like the URL, the headers, whatever, then the content will not, or there's a idempotent just means it doesn't change. So same thing if you delete. If you delete something once, it's deleted, it's gone. If you delete it a second time, it's still deleted. You can't delete it more. And then there's neither. So you can have safe, idempotent, and neither. And post is neither. And then there's a bunch of other things that are neither. But you can imagine a system where under the hood, you have resources that either accept GET or POST. And the URL for those resources is separate, and then you can rewrite the URL to the address of the thing. And I mean, the other thing too about state and post and whatever is that like it's just there's no guarantee, right? Like the extent to which the state changes is up to the application. There's no guarantee at the protocol level about it anything that's going to be sent. Not that there's a guarantee anyway, but there's a sort of a normative should be a guarantee, even though in practice there's never really a guarantee. So, and the other thing too I want to say here is also there's a representation class. And that is like a monad, basically, that the transforms accept and return a representation. And a representation is kind of monad-ish. The extent to which it's a monad sort of depends on what language you write it in, but it's basically monad-ish. And the idea behind this is, let's say you have a transformation function that crops an image. Well, it's going to have to parse that image into memory, or it's going to have to put it into some sort of internal representation so it can run the function over it. And then it's going to still have that kicking around. And so you've got the bytes of the file that is the initial sort of representation that was read off the disk or off the network or whatever, and then you have the sort of in-memory representation. And the idea behind that is if you want to crop it and then you subsequently want to resize it, well, you would have to serialize it and then reparse it, and that costs resources. And it's like, well, why would you bother with that? Like, why would you not just keep the in-memory representation around until you knew you didn't need it anymore? So that's kind of the idea behind the representation monad-ish thing. It would also have like mtime, content type, content language, content, whatever, all the other sort of content, char set's in content type. It would have encoding, whatever, all that shit. And the idea is the transforms would, again, the transforms are multiple. They go in a stack, and so like, and this I don't really know what to do quite yet with, other than to say, that by the time the request hits the dispatcher, it should be sanitized. And then it should be sanitized and rewritten to sort of be flattened out into the smallest possible set of possibilities. That's sort of the scheme with that. So this is actually helping me a lot here. I'm going to just put the date. This is actually helping me think about this a lot. Because where it's at right now, is like, I want to kill this document thing and the ops. So the ops go to transforms. The repository goes to a surface type, the static surface type. So that's going to basically be equivalent to a static site generator like Jekyll or whatever, 11e. And so the document class has to be killed. Actually, I'm just going to like... Ooh. Come on. Are you on there? No, you're not. Oh, I moved it. Yeah. I need to get markers. I need to get nice colored markers. Anyway, we'll just Sharpie it. What's this guy? 0.5. Okay, sure, whatever. So we will circle, or not circle, but we will make the classes those are the classes right now. And then these are operations. Those are just code, like those are just functions that need to get turned into, they need to get turned like normalized out as well. So underneath, that's interesting. I thought I had autofocus off. I set the focus and then turn off autofocus so that it doesn't bug out. So I think the resolution here, oh, and I guess we can, this is a class. This is a abstract class. And then like how these get generated, this is going to be a little bit difficult because say for example like the generated ones, those are either going to be specific addresses that are generated. So like, let's say a sitemap, you know, or what have you. There's specific identities, or they're going to be specific classes like a feed. And those are going to have access to, you know, say the graph for starters. In order to generate their content. And there's going to be other stuff in the generated pile too. The point, though, is to ensure that like all of the URLs that ever get exposed to the user, and we can just put like a frickin', you know, a wall up there. Like all of the URLs that ever get exposed to the user are always durable. And yeah, so I think like manipulating the request, something that manipulates the request, I definitely need like a class for that. Like I need like an actual piece of code, or like I'm gonna have some dedicated piece of code that manipulates the request, and it does things like, yeah, prepends to the transform stack. So like I said about the markdown, and then there has to be some kind of semantics for like the markdown has to go first, right? Like, so the thing comes out of the, so what happens here is that like you've got the file system source. It poops out a representation that's going to have like just byte stream of the markdown file. But that's going to hit the markdown to HTML transform, and then like that's going to open up like a DOM object, which can get passed to all the other transforms down the line, and then that hits the surface, and then whatever the surface does with it, if it sends it as a over the wire, or if it writes it to a file or whatever, like that's its prerogative, what it does. So then all you have to do is like fake up, like if you wanted to have like a static site generator there, you would just fake up a bunch of requests to the content. It would do this, whatever's on this side, it would come through the pipeline, and then it would just, you know, once it hits the surface, it would just like poop out to a file. Or a set of files. It would just dump stuff into a folder. You could rsync that folder to the server, you know, and Bob's your uncle. If it's a live system, then something else needs to happen, like some other system. So you could also say preempt, like if you didn't do anything but get on the surface, then or if you did something other than get, it could say method not allowed because the surface just does not permit it. So and then the other thing too is I mean, there's going to have to be like access control, like in there somewhere. But if you say had like a request to a proxy, for example, and you would rewrite the request URL to have it respond via proxy, you know, you would like rewrite the URL to a thing like by this point, it should be like UUID, maybe and maybe path parameters and a request method. And then the UUI at this point, UUID or hash. And then what's cool about this whole thing is you would write this all in one language, potentially. You might be able to like have some kind of like, and this is going to have to get fleshed out, like some kind of a reverse proxy in the transform place. Because eventually what I want to be able to do is I want to be able to have transform services and there can be like short circuit. So let's say that one of these transforms exists on another server written in another language, and you literally just pipe the bytes into it of the representation, and it will give you back a representation that you that is consistent with the transformation function. And then at that point, you can cache that in a content addressable store. And furthermore, is if you've already done this, it's cached. Oh. Anyway, I got a call I got to take, so sayonara for now.